Okay, I'm going to talk super duper fast, so feel free to utilize pause and rewind on this action. Alright, so you should know your explicit formulas for arithmetic and geometric sequences. You should further know that arithmetic goes on a linear path while geometric goes on an exponential path, meaning that their formulas and the way that their sequences climb is growing in these rates. So, how do you know when to use each one? That's basically it. That kind of answers that question. And remember, arithmetic's when you're adding or subtracting the same thing each time, and geometric's when you're multiplying or dividing the same thing each time. So now, sequences can come in the real world as well. So if you read this problem here, it's talking about the rate that a business is growing and different data points throughout the year. So in month 3, okay, in month 3, we have $617 per day that we're making, and then in month 7, 4, 5, 6, 7, it's $11.04 per day. Now the reason I drew it out this way was I was thinking of it as a sequence as I read the problem. So first data point is when n is 3, and then when n is 7. Use this information to find the common difference of sales per day. Alright, now I realize some of you already know that this is a word problem from Algebra 1, and it's basically a linear problem. And you could do it with a y equals mx plus b, but I'm trying to show you how you can tie it into sequences as well. So what I would do to find the common difference, aka slope, is I would figure out basically like the common difference. Well, I know that the difference is I have to travel 1, 2, 3. I have to travel 4 spots, and in those 4 spots I have to make up the difference of whatever 617 to 1104 is. So for me, I'm going to subtract those two numbers and get the total difference and divide it by the distance that I need to travel. And what that's going to give me in the calculator, I hope, let's see if I have that number, is, ooh, it's giving me a fun fraction here, 121.75. So what that means is that that's how much money we are making per day. So what I'm going to do is, if I'm reading this correctly, it wants me to find the first month the business was open. Well, to find that, I can just work backwards, right? So I can take my 617 and work back to my A1 term and subtract this number twice. And whenever I do that, it looks like I'm getting $373.50. So that's going to be my A1, and now we can write a formula for this sequence, which is arithmetic, by the way. So our arithmetic formula is here, right? A1 plus the common difference times n minus 1. The first term, 373.50, plus the common difference, 121.75 times n minus 1. This, kids, is my formula. I can use this to make predictions for any month of the year. This did say the end of the year, though, so how many months in a year? 12. So if you want to plug in a 12 right there, you can crank that out and get your final number for what's happening at the end of the year. So now we're going to look at the same situation, so the same data from above, but instead of it growing at a constant rate, it's going to grow at an exponential rate. What this means is if you see that word exponential, we do need to start associating that with a geometric sequence. It means we have a common rate or a common multiplier. So what I'm going to do is very similar. 617. And what was that other number? 1104. Okay, so what I'm going to do is I need to travel, same kind of a deal. I need to travel 4 spots to get from this number to this number. So I'm starting at 617, but I travel differently. I'm not adding the same thing each time. I am multiplying by r each time, right? So I need to multiply by r to the 4th, because it's like times r times r times r times r. And after I do that, I'm going to get 1104. So now I just have to solve for r. So this is just some algebra. I'm going to divide the 1104 by the 617. So I'm typing this in as I'm doing it. So hopefully I type it in right. I'm getting 1.789, la 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 la. Now I'm going to take the fourth root of that, or if you don't want to find the button for the fourth root, you can take this to the 1/4 power, right? That'll do the same thing. So let's take that to the 1/4 power, and we are going to get a rate of 1.15. I'm going to round it right here, so 1.157. So if this is my rate, okay, I'm going to go ahead and start to plug into my formula. Now A1 times R to the n, oops, I left off my 7. All right, to the n minus 1 power. Now, I don't have my A1, so how do I get it? Well, earlier I subtracted off my common difference twice, but I don't subtract here because remember this pattern is established through multiplication. So if I'm working backwards, I need to divide off 1.157 twice. So I'm going to take 617. I'm going to divide it by 1.157 the first time, and that gives me my A2. It's like 533-ish. And then I'm going to divide again, 157. Is that right? 1.157? Okay. And then I'm getting a 460.91 cents. So that's going to be the A1 that I put in here. 460.91. And then same thing, this could be used to make predictions, so I could plug in a 12 to get the end of the year, yada yada yada. Alright, cool. So hopefully this is kind of starting to come together with how you could use these in the real world. Now ACT, SAT, yeah, they like to do different things. So how many terms, this is exactly actually a couple questions I've seen before. How many terms are in the following finite sequence of numbers? Alright, well finite just means that it ends, so it's giving you the start, so this is your A1, and then it's giving you the last term, which is your AN. Your goal is to figure out how far out this fellow went to get to that term, okay? So look for the pattern, you know. Let's see, we're going from a 6 to a 3 to a 3/2 to a... I think what's happening here is we are multiplying by a half each time. So I'm going to start with a formula. A sub n equals, what's my A1? So 6 times my rate to the n minus 1 power. Now I don't know n, you know, like that's what we're trying to find. So what I'm going to do is take what is in that last spot already and plug it in right here. And then I'm going to solve. And actually, for the sake of time on this video, I'm not actually going to solve. Well, I should because it's logs and everybody loves logs, right? Okay, so what I would start by doing is taking this 3 over 1024, 3 divided by 1024, and then I'm going to divide off the 6, right? Divide everything by 6. And when I do that, I am getting a tiny little decimal. It's point to the fourth, 0.00488, okay? That's what I'm getting on the left, and that's equal to 1/2 to the n minus 1 power. Now, my n is stuck in my exponent, right? So there's a reason we did this chapter after logarithms, everyone. I'm going to rearrange this as a logarithm. So log base 1/2, remember the base stays the base, and then these two things swap out. 0.00488 equals n minus 1. And then we'll go from there. So for me, I'm typing this in currently as the change of base formula. So I'm in my calculator and I'm typing in log of 0.000488 divided by log of 1/2. And that gave me a number close to 11, like really stinking close. So close to 11 that I'm going to leave it as an 11. So for me, I'm getting 12 terms, right? If I move that 1 to the other side. So this right here is the 12th term out of the sequence. All right, cool. So now how about this one on the bottom? All right, so how about... what's happening? Can you tell? Okay, I think I see that we're subtracting 3 each time, right? So, same thing. I know that it's arithmetic, so I'm going to start filling into this. I know my A1, it's the first term, right, is 5. I know my common difference is a -3, so let me change that to -3. I don't know my n, right? But what do I know? I know that it needs to end at the number -70. So that's like my final answer. So I'm going to put it in the spot of AN, just like I did above. Only difference between these two is knowing which formula to use, and then you're going to solve. This one's easy. I'm not going to solve it out, but you could. All right, so let's see if we want to move on to the next. Oh, yes, we do. I think I'm going to make a separate video for moving into series because this is already 10 minutes and somebody might need to go to the bathroom or get a drink of water or stand up and stretch or slap your neighbor.